Hello, welcome to Lesson 2, Master Class in Algebra for JSS1 to SS3. Today's topic is addition, subtraction, multiplication, and division of algebraic expression. By the end of this lesson, students should be able to identify like and unlike terms. They should be able to add and subtract algebraic expressions. They should be able to multiply algebraic expressions by numbers. They should be able to divide algebraic expressions by numbers. And lastly, they should be able to solve simple real-life algebraic problems. So let's try to do this starter activity. Simplify the following. Now we have 5 plus 8. 5 plus 8 we know is equal to 13. This is not an algebraic expression because we don't have any letters there. This is just 5, a number, plus 8, another number, and it's equal to 13. Question number 2 is an algebraic expression because it contains letters. And we know that from a previous lesson that these letters represent unknown numbers. Now here we have 4x plus 2x. Now another thing we can see about this algebraic expression is that the letters are the same. The first number or the first expression is 4x plus the second expression 2x. So the first expression contains x. The second expression also contains x. Now what this means is that we can, because the letters are similar, we call them like terms. And because they are like terms, we can add them together. So 4x plus 2x is equal to 6x. Look at question number 3. Question number 3 is 7a minus 3a. This is a similar algebraic expression to question number 2. 7a minus 3a. The unknown number here represented by a in the first expression is the same as that in the second expression. So this means that because the terms are similar, they are like terms, therefore we can subtract 3a from 7a. So 3a minus 7a or 7a minus 3a is equal to 4a. Question number 4. 5 multiplied by 3x. 5, the constant, is multiplying the expression 3x. The result is going to be 15x. So 5 will multiply 3. And the result is 15x. Discuss why question 2 and 3 can be simplified. The reason why question 2 and 3 can be simplified is because the terms are similar. Question 2, the algebraic expression contains, the first expression contains x, the second expression contains x. They are like terms. Therefore, it is easy to simplify. The same thing applies to question number 3. In the starter activity we did, there was something we saw there, something kind of peculiar, let me put it that way. We saw that in question 2 and 3, the algebraic expressions were the same, they were similar. They contained the same letter, and because of that, we're able to easily simplify those expressions in question 2 and 3. Now, we're going to be looking at like terms. And this is the reason why we were able to easily simplify question 2 and 3, because the terms were similar. There was x in the first part of the expression, and there was x also in the second part of the expression. So we could easily add the both terms together. Now, so like terms have the same variables raised to the same powers. So in an expression, the terms that are alike, they should have the same variables, like we saw in the starter activity, where question 2 contains variable x and question 3 contained variable a. So the expression should contain the same variable. And if the variables are raised to powers, the expression should also be raised, the terms inside the expression should be raised to the same powers. So if this is so, then we can now say that they are like terms. So let's look at some examples. Here we have 5x and 2x. Now these two expressions have similar variables. The variable here is x and the variable here is x. Therefore, we can say that these two terms are like terms. They are alike because they contain the same variables. So in the second expression, we have 8y and minus 4y. So these are also like terms because the variables are similar. So it is not the coefficient 8 and minus 4 that determines whether the expression is similar or whether they are like terms. It is the variable. So once the variables are the same, once they are similar, we say they are like terms. Now look at the next expression, 7a squared minus 3a squared. Here again, these are like terms. Now why are the expressions like terms? The expressions are like terms because the variables are the same and they are raised to the same power. This is 7a raised to the power 2, this is 3a raised to the power 2. So both of them are raised to the same powers. Therefore, they are the same. Therefore, we can now say that these two terms are like terms. But the coefficients are different. The coefficient here is 7, the coefficient here is 3. So they are unlike terms. But the expressions are like terms because the variables are the same and they are raised to the same powers. So we determine whether terms are similar or whether they are like terms based on the similarities of the variables, not the similarity of the coefficient. Unlike terms. Now, unlike like terms, have different variables or different powers. So, example, 5x and 5y. Now we can see that the variable here is x, while the variable here is y. And even though the coefficients are similar, because we have 5 here in this expression and we also 5 here in this expression, these two expressions are unlike terms. Why are they unlike terms? Because the variables are different. So we have x here in this expression and we have y in this expression. In this scenario, you cannot add these two values. So if you are asked to simplify 5x plus 5y, the result is still going to be 5x plus 5y. So if you are asked to simplify this expression, the result is going to be 5 multiplied by x plus y, which if expanded, if we remove the bracket, you are still going to get back 5x plus 5y. But we cannot add them together because the variables are different. X and y raised to the power 3, or x and y raised to the power x cubed. And these two are the same variables, but something else is missing. Why we can't add these two together? The powers are different. The first expression is raised to x is raised to power 1, while the second expression is raised to power 3. So in this case, we cannot say that they are like terms, they are unlike terms. They are not the same. 4a and 4ab, 4a and 4ab. These terms are also unlike terms. There is a in this expression, there is also a in this expression, but b is not present in this expression. So we can't add these two expressions. If we're asked to simplify this expression, the result is going to be 4a multiplied by 1 plus ab. Oh, sorry, 4a multiplied by 4a 4a multiplied by 1 plus b. If you use 4a to multiply the values inside the bracket, you are still going to get by 4a plus 4ab. So 4a multiplied by 1 plus b is the simplified version of 4a plus 4ab. So only like terms can be added and subtracted. So if the terms are not alike, you cannot add them and you cannot subtract them. Addition of algebraic expression. Add only the coefficient of like terms. So let's look at an example. Simplify 3x plus 5x. Solution. 3x plus 5x. We're asked to simplify this expression. And how do we go about it? We are to only add the coefficient of the expression. We cannot add the variables because they are letters. So we are going to add the coefficient. So the coefficients are 3 and 5. Therefore, 3 plus 5 is equal to 8. Because the variables are similar, we just write x here. We take one of the x. This expression can also be expressed as x multiplied by 3 plus 5. Now, because x is common, we have x here and we have x here. We pick one x and put it outside the bracket. Now, if we multiply through, if we use x to multiply the value inside the bracket, we are still going to get back 3x plus 5x. So the result is going to be x multiplied by 8, which is the same thing as 8x. So when we are asked to add two like terms, we only add the coefficient. Addition of algebraic expression. Example, to simplify 4a plus 6a plus 2a. Solution. 4a plus 6a plus 2a. Now we can see that there are three expressions here, 4a, 6a, and 2a, and we have to add them together. Now, we can also see that the three expressions have like terms. The variables are the same. Therefore, it is possible for us to add them together. But for us to add them together, this is what we are going to do. So when we have this type of scenario, this type of case where we are asked to add like terms together, now the part of the expression that we are going to add together is the coefficient of the expression. So this algebraic expression can also be represented as a multiplied by 4 plus 6 plus 2. And therefore, this is the same thing as a multiplied by 12, which is the same thing as 12a. So what we did is that we added the coefficients, or we summed up the coefficient. And then because the variable is common, because it is common, we represented the variable with the letter A. Example 2. Simplify 4a plus 6a plus 3a. Solution. 4a, the expression 4a plus the expression 6a plus the expression 2a. Now we can see that this expression, these three expressions are like terms because they have the same variable, a letter a. And so because they are like terms, it is possible for us to add the three expressions together. And we know that when you are adding like terms together, it is not possible for you to add the variable letters. So what you do, you take a common letter, which is a like term, and then put the coefficients, in this case, inside the bracket. So what we have to do now is to find the sum of the coefficients. And the sum of the coefficients here, 4 plus 6 plus 2, is equal to 12. So 12 plus the letter A is equal to 12A. So this is the simplified version of 4A plus 6A plus 2A. Example 3. Simplify 5x plus 7 plus 3x plus 9. So solution, 5x plus 7 plus 3x plus 9. The first thing we need to do is to consider the terms. Alright? So we have 5x, we have 7, we have 3x, and we have 9. Now we can see that we have a common variable, x. 7 and 9 are constants. They are not multiplying any variable. So how do we go about solving this kind of problem? So the first thing we have to do is to collect like terms, and the terms that are alike. And we know that the terms that are alike here are 5x and 3x. So we are going to write 5x plus 3x plus 7 plus 9. Now look at the method I'm going to use. I'm going to group 5x and 3x because they are like terms. I'm also going to group 7 and 9 because they are also like terms. They are constants. Okay? Now we know that 5x plus 3x, if we are adding two like terms like this together, what we do is to add the coefficients and then take the common variable. Right? So in this expression, it's going to be x multiplied by 5 plus 3 plus 7 plus 9. So 5 plus 3 is 8. Plus 7 plus 9 is 16. Right? And this can also be written as 8x plus 16. Therefore, 8x plus 16 is the simplified version of 5x plus 7 plus 3x plus 9. Alright, so example 1. Simplify 9x minus 4x. Solution. 9x minus 4x. So something that is very clear here that we can easily see is that again, there are two expressions here that